The next change that we want to look at with our sine and cosine functions is called a change in period. This changes the horizontal distance, or the units that are required to complete one full cycle. When we look at a change in period comes from multiplying the inside of the function by some value. So when I look at y equals sine 2x, now the input for my sine function has been changed to 2 times x. Now notice that we have not multiplied the front of the function by anything new. And in a way, we can think of that as like an implied 1 times our sine function. So the amplitude is actually still 1, but now the period has changed. Let's see what the period now will be. Let's see how it affects the graph if I multiply the inside by 2. So y equals sine 2 times 0. Now keep in mind that this is the input of our function. So that gives me 2 times 0 is 0. Sine of 0 is 0. Now our x value would be pi over 4. 2 times pi over 4. What we see here is that if I think about this as 2 over 1 times pi over 4, the 2 and the 4 have a common factor of 2, so that's really like pi over 2 as our input. Sine of pi over 2 is 1. So our angle gets doubled, and then we take the sine value of that angle. Pi over 2, when I double that or multiply it by 2, we get pi. And sine of pi, that y value would be 0. If I double 3 pi over 4, I get 3 pi over 2. And sine of 3 pi over 2 we know is minus 1. If I double pi, I get 2 pi, and sine of 2 pi is 0. If you notice, these values should look familiar. We've actually gone through a complete cycle of all of our sine values in pi units. So in half the time, we have actually cycled through all of our sine values. The same 5 sine values that we got when we graphed to sine the original graph from 0 to 2 pi. So what we actually have is an x value of 0, we get 0. At an x value of pi over 4, and pi over 4 is half of pi over 2, at a x value of pi over 4, when we put that into the function, we got an output value of 1. Pi over 2 went into the function as our x value, and that comes out as 0 for our y value. The next value put in was 3 pi over 4, which is halfway between pi over 2 and pi. It's the midpoint between those 2 points. We get minus 1, and then when we put pi into the function, we doubled it, and it came out with a sine value of 0. So we see that we actually go through a complete cycle, or a period, of our sine function between 0 and pi. So we would say that the period is pi. Now if I keep going, I'm just going to repeat the same values. So if I double 5 pi over 4 and take the sine value of it, then I get 1. We double 3 pi over 2, take the sine value of it, I get 0. And then we get minus 1, and then we would get 0 again. So we would actually be able to graph 2 periods, 2 cycles of our sine function in the same space that we graph the complete sine function, one cycle of the complete sine function before. So we see that we actually have 2 cycles and now our period is pi. So the period actually is going to be found by taking 2 pi and dividing by b. So the value that we multiplied on the inside of the function is called b. We would say that's b. 2 pi divided by the number that's multiplied times the inside of our function. So that would be 2 pi, and here our number that we multiplied on the inside of the function was 2. 2 pi divided by 2 pi. So that tells us that the horizontal distance, or the amount of units required to complete one full cycle of sine, would just be pi units. So the coefficient b, the number we multiplied on the input, the inside of our function, represents the number of times that sine will complete a full cycle between 0 and 2 pi. So we see that here we completed 2 full cycles of sine. If we change the coefficient of x, that will change the period of the function. The input angle is now bx and will cycle through all angles from 0 to 2 pi. So our x values will go from 0 to 2 pi divided by b. So for both sine and cosine, if I want to find the period of the function, I take 2 pi and I divide it by the number that's being multiplied times x on the inside of our function. And that will tell us the period of our function. When we make changes to the inside of the function, that affects the graph horizontally. In other words, it changes the x values that will be used for the graph. To find the x values that will be used for the graph, if we change the period, so we have any kind of horizontal change, the x values will change. And we will find the x values by first putting the inside of the function between the values 0 and 2 pi. 0 and 2 pi are the original start and end of the basic graphs of sine and cosine. We will put the inside of the functions, whatever changes are made to the inside, in between 0 and 2 pi, and then we will solve for x. And this will give us the new start and end points for that one period. Then we will find the midpoints and separate our graph, or separate it into 4 equal segments. So let's say that we want to graph y equals cosine of 1/2 x over a 1 period interval. The amplitude is the number that's being multiplied out front, outside of our function, and that's an implied 1, so our amplitude is 1, and that's our a. The b is the number that's being multiplied times the inside of the function. So 1/2 x is our input, so our b is 1/2. To find the period, we will take 2 pi and I will divide it by b. So that would be 2 pi divided by 1/2. Anytime that we divide by 1/2, or divide by any fraction, we're going to flip the fraction and multiply it times the top of the fraction. And that gives me actually 2 times 2 is 4, so that gives me a period of 4 pi. To see where we start and where we will end, we will take the original starting and ending places of our function, which is between 0 and 2 pi, and now we will take the new inputs, 1/2 x, and we will put that in between. And we want to solve for x. So to solve for x, I need to get rid of this 1/2. I'm going to multiply everything on all 3 parts by 2. We're going to multiply by the reciprocal. 2 times 0 is 0. 2 times 1/2 is 1, or just x. 2 times 2 pi is 4 pi. So our new start and ending x values will be 0 and 4 pi. So 0 will be our starting, 4 pi will be our ending. Now we want to find the midpoints. The x values are separated into 4 equal segments. So what's halfway between 0 and 4 pi? We could add together 0 plus 4 pi and then divide by 2. And of course that would be 2 pi. What's in between 0 and 2 pi, and the direct middle of those would be pi. And then the midpoint between 2 pi and 4 pi, if I add together I get 6 pi and divide by 2, and we have 3 pi. So we have 4 equal segments. We have 5 x values that separate our graph into 4 equal segments. So we want to find those x values, and then we're going to graph our cosine basic shape using these 5 values. So cosine starts at the maximum, comes down to the x-axis, and then goes down to a minimum, comes back to the x-axis, and then at the last point it's at its maximum. So we have our basic shape of cosine with a period of 4 pi.